All right, so just quickly going to talk about, derivatives of logarithmic function. This builds on what we've done previously. We've done a few log functions already, differentiating them. These ones here are ones where the log laws become really important. So at the moment, we've got a rule, which I'm just going to put up here, which is y equals ln. And if we have a function in here, then our derivative becomes the derivative of the function, the bit that's inside the logarithm, over the original function. Now, if you look at this thing here, this would mean that if we were finding dy dx, we could go, oh, well, it's going to be the derivative of this thing over e to the negative x. Now, x e to the x. Now, the issue with this is a product rule. So we're now all of a sudden looking at, it's going to be, we're going to have 1 e to the negative x plus, x e to the negative x times negative 1. So I've sort of sped through a product rule. So it's a little bit more involved, and some of the examples here get quite complex. Now, I'm trying to think of, we'll leave that there. Instead of doing that, what can make this a really simple problem that we can just go through methodically is we can actually apply the log laws here. So we can go, well, we've got y equals the natural logarithm of x e to the negative x. So these are multiplied together, which gives us one of our log laws, which is x. So logarithm of x plus logarithm of e to the negative x. Now I'll quickly change color so I can write my log law in that I've used. So this is ln a plus ln b equals ln a times b, which is the rule we've applied there. Now, as personal preference, I like putting brackets around those. Now we've got this in parts, we can actually go, well, the logarithm, the derivative of the natural log of x is just 1 over x. And then the derivative, well, this thing here actually simplifies out further. So I should have done that in the step before. This and this cancel, so this would just be negative x. And so the derivative of negative x is just going to be negative 1. All right, now I should have specified that ln e to the negative x, they would cancel and I'd be left with just negative x there. All right, good one. Now, that's it for that one. We've got our derivative, which is correct, and that was in the simplest form as we need it. So we're now going to come to this one here. So we've got b, our question b, y equals the natural log of this big expression. Now, the first thing to notice is that we've got a fraction. So we can break this apart by going, well, y equals ln x squared minus ln x plus 2 x minus 3. Now, I'm going to put a big square bracket to just so we know that's still inside. And the rule we've used here is ln a over b equals ln a minus ln b, or natural log b. Now, let's apply our rule from that we did over here. So we've got two things multiplied together, so let's simplify it further. So we're going to get y equals ln x squared minus, now I'm just going to put that minus there because this is going to break into multiple terms. So ln x plus 2 plus ln x take 3. All right, and close that bracket there. And so now if I expand that, I've got y equals ln x squared minus ln x plus 2 minus ln x minus 3. And while this is a bit of work, now when we do the derivative, we go dy dx, and the derivative of this is going to be 2x because the derivative of x squared is 2x over x squared. The derivative of our next thing is going to be minus 1 over x plus 2. And that's because the derivative of x plus 2 is 1. And then our original function on the bottom. And then our final one here is minus 1 over x take 3. And now we would quickly cancel out this x and this x here. And so our final expression for our derivative is dy dx equals 2 over x minus 1 over x plus 2 minus 1 over x minus 3. All right, thanks, guys.